When I was a kid, I used to think light was just light. You flip a switch, the room gets bright, and you go on with your life. But there's something strange about that. The more you look at it, the more it feels like the universe is playing a little joke on you. Here's the funny part in school. They teach you that light is a wave. Then later, they teach you that light is a particle. And if you're lucky, they might mention that it's both. But if you think about it, that's a bit like saying a chair is a wave, also a particle, and sometimes it's a chair. That doesn't sound like a clear explanation. It sounds like a magician saying, no, you see it, now you don't. And you're supposed to clap. Now here's the paradox that gets you right in the brain. If light is a wave, it should spread out, right, like ripples in a pond. But light also travels in straight lines, like tiny bullets. You might think, well, maybe it's both. But then the universe goes and does something even weirder. It says, oh, you want to test whether I'm a wave or a particle? Fine, I'll behave differently depending on whether you're watching. That's not a joke. That's an experiment. Let me give you a thought experiment, a simple one. Imagine you have a very small light source and you shine it through two narrow slits onto a screen. You might expect two bright lines, right? Two slits, two beams, two lines. That's what your common sense says. But what actually happens is you get a pattern of many bright and dark stripes, like a series of ripples. That's a wave. The light from each slit spreads out, interferes with the light from the other slit, and creates a pattern of constructive and destructive interference. So far, so good. Light behaves like a wave. But now, here's the part that makes your head spin. If you turn down the light so much that only one photon at a time passes through the slits, you still get the interference pattern, eventually, one photon at a time, like tiny particles. Yet, over time, the pattern builds up as if each photon somehow knew about both slits and interfered with itself. Now hold on, how does one photon interfere with itself? It's like throwing a single pebble into a pond and watching it make a ripple that interferes with itself. That's not a thing that should happen in any ordinary world. And the universe doesn't stop there. If you try to watch which slit the photon goes through, the interference pattern disappears. The photon behaves like a particle again. The moment you look, it becomes real in a different way, like a shy animal that changes its behavior when it knows you're watching. This is the paradox light seems to be telling you. I'm a wave, until you try to pin it down. Then it says, no, I'm a particle. And if you try to catch it in the act, it says, you can't catch me. I'll be what I need to be. Now, you might think that this is just a weird feature of physics, like an odd rule in a board game. But it's not. It's not a quirk. It's the rule. It's the thing that tells you the universe is not built the way you thought it was. Here's the deeper point. When you're young, you think the world is made of objects. Things that are either here or there. Solid, defined, certain. But light and quantum mechanics in general doesn't work like that. The world doesn't always give you a simple either or. Sometimes it gives you both. And then it gives you neither. And then it gives you something that's not even a word in your language. It's not that the universe is trying to trick you. It's just that your brain is built for a different world. Your brain evolved to handle rocks and trees and other animals. It didn't evolve to understand what happens when you look at something smaller than a grain of dust and try to ask it a question. And light is the first place you run into this problem, because light is how you see everything. It's the messenger that brings information to your eyes. If the messenger behaves like a wave and a particle at the same time, what does that say about the message? What does it say about reality itself? Let me tell you a little story. When I was a kid, I used to go fishing. I'd stand on the edge of a river and I'd look at the water, and the water would look smooth, calm. But if I threw a stone in, suddenly the water would reveal its hidden nature, ripples, waves, patterns. And I'd think, aye, so that's what it's like under the surface. Light is like that. When you turn on a light, you think you're seeing a simple thing. But if you do the right experiment, the light reveals a deeper nature. It shows you the hidden rules. The strange thing is that we don't see these rules in everyday life. You don't notice the interference pattern when you walk into a room. You don't notice that photons are behaving like waves and particles at once. It's only when you start looking at the world in a more careful way that the universe shows its true face. And here's what's really amazing. The world doesn't care whether you understand it or not. It behaves the same way whether you're thinking about it or not. It's just that your mind is trying to force it into a box that it doesn't fit into. So you're standing there with your light switch, thinking you understand what light is. But the moment you start to investigate, the universe says, oh no, you don't. Not that easily. Now, there's a part of this that's deeply unsettling and a part that's deeply beautiful. It's unsettling because it shows that certainty is not as common as we think. It's beautiful because it shows that the world is richer than our simple models. It's like realizing that the painting you thought you understood has hidden layers and colors that only show up under different lighting. And that's what's so thrilling about light. It's not just about seeing, it's about understanding how the universe decides what is real. You might think that the real world is what you see, but the more you learn about light, the more you realize that what you see is only one version of reality. And reality itself is not a single thing. It's a set of possibilities, and your measurements are what choose which possibility becomes the one you observe. Now, if that sounds too philosophical, don't worry. It's not philosophy. It's physics. It's just that physics, when you dig deep enough, starts to look like philosophy because it forces you to ask questions that your everyday experience never prepared you for. And that's why the story of light is so important. Because it's not just about beams and waves. It's about how we know anything at all. It's about how the universe answers the questions we ask. So you see, light is not just a thing that makes things visible. It's a kind of language. And the more you study it, the more you realize that the universe is writing a story in a script you didn't even know existed. If you're still thinking, well, that's all very interesting, but what does it mean? Then you're in the right place. Because the next part of the story is where the fun begins. And it starts with a few simple experiments and analogies that make this strange behavior feel less like magic and more like, well, like nature. All right, good. Let's keep going. So we've already stumbled into the strange truth that light behaves like both a wave and a particle, and it changes its behavior depending on whether you're watching. That's the part that makes you say, wait, what? But the next part is where the universe starts to become not just weird, but almost understandable. Not in the sense that it becomes simple, but in the sense that it begins to feel like a consistent story. And that story starts with an idea that's so simple it almost feels like cheating light isn't either a wave or a particle. Light is what happens when the universe is forced to answer a question. Now, let's not get ahead of ourselves. First, let's think about what we mean when we say wave or particle. A particle is like a tiny billiard ball. It has a position, it has a trajectory. You can say, at this moment the particle is here, and it's moving this way. A wave is like a ripple on a pond. It spreads, it interferes, it doesn't have a single position. It's more like a pattern. Now, you might think, okay, but light must be one of those. It must be either a wave or a particle. The universe can't be that ambiguous. But here's the thing, that assumption that the universe must choose one identity and stick to it is something we learn from our everyday world. We learn it because everything around us behaves that way. A baseball is a baseball. A water wave is a water wave. You don't see a baseball suddenly acting like a wave. Not unless you throw it into a pond. And then it becomes a wet baseball with ripples around it. Light is different. Light is not just a thing. It's a process. It's a story of how something travels and interacts. And it turns out that the story depends on the question you ask. Let me give you a vivid analogy, because analogies are the way we humans wrestle the universe into a shape we can hold. Imagine you're watching a magic show. The magician has a coin and he puts it into his left hand. Then he closes both hands. You don't know which hand it's in. You ask him, which hand is it in? And he opens his right hand and shows you nothing. The coin is in the left hand. Now you might think, well, the coin was in the left hand the whole time. But here's the twist. What if the magician is doing something different? What if the coin is not in either hand until you ask the question? What if in the magician's world the coin is in a sort of both hands and neither hand state until you force it to choose? Now, you might say, that's ridiculous. Coins don't behave like that. And you'd be right, coins don't. But photons do. Now, before you accuse me of making up magic, let's step back and look at what's actually happening with light. There are experiments you can do with light that are so simple you could do them in a kitchen, and yet they reveal this profound truth. One of them is the classic double slit experiment. Another is something even simpler, reflection and refraction. We all know reflection. You shine a light on a mirror and it bounces back. Refraction is when light passes through a glass of water and bends. That's why a straw in a glass looks bent. And we explain these things using waves. We say the light wave slows down in the water and the wavefront changes direction. That's the standard explanation. But then if you ask, why does light bend in glass? The answer you're given is usually because the speed of light changes in glass. But that's not quite right, because the speed of light doesn't change the way you think. The speed of light in a vacuum is a constant. That's the speed limit of the universe. What changes in glass is the way the light interacts with the atoms in the glass. Here's the thing: the atoms in glass don't just let the light pass through. They respond to it. They get excited. They vibrate. They send their own waves back out, and those waves interfere with the original light. The result is that the light appears to slow down, but it's not like the light is running through molasses. It's more like a conversation. The light is constantly being absorbed and re-emitted by the atoms, and the combined effect is what we observe. And that's a clue, because it suggests that light isn't a thing that just travels through space. Light is a process of interaction. It's an exchange. Now, let's think about this in terms of something you can feel in your own body. Think about how you can hear sound. Sound is a wave. It's pressure waves traveling through air. But when you're in a crowded room and people are talking, you don't hear every voice separately. You hear a blend. The waves interfere. Some sounds cancel out. Some sounds amplify. Now, imagine if you could ask the air, which person's voice is this? And the air says it's all of them and none of them, until you decide to listen carefully. That's what light is doing. It's not a single voice. It's a superposition of possibilities. And this is where the analogy starts to get powerful, because when you look at the double slit experiment, what you're really seeing is not a photon choosing a slit. You're seeing the possibility of both slits. The photon doesn't go through one slit or the other. It goes through both in a sense, and the interference pattern is the record of that possibility. Now, this is the part that people get hung up on. They think, well, the photon must go through one slit or the other. It can't go through both. But that's because you're thinking like a classical physicist. You're thinking in terms of objects. You're thinking in terms of things that have a single, definite path. But the universe doesn't always work like that. Sometimes it works in terms of possibilities. And here's the amazing thing: those possibilities aren't just mathematical tricks. They're real. They're real enough to create interference patterns. They're real enough to affect the outcome. It's like the universe is saying, I don't commit to a single path until you force me to. Now, let's make this more concrete with a simple experiment you can do with your own eyes. It's not the double slit, but it gives the same flavor. Take a CD or a DVD, hold it up to a light, you'll see a rainbow of colors. Why is that? Because the surface of the disc has tiny grooves. The grooves act like a diffraction grating. They split the light into different directions depending on wavelength. The light behaves like a wave. It interferes with itself. It makes a pattern, but then you look at the disc from a different angle, and the colors change. The pattern changes, and you realize the light is not just a single beam. It's a whole set of possibilities, and the angle you look at it determines which possibility becomes visible. That's the weird part. The light is not just traveling, it's telling a story, and the story changes depending on the observer. Now, I know what you're thinking. You're thinking, okay, that's all interesting, but why does it matter? Why does it matter that light behaves like this? It matters because light is the way we measure the world. Light is how we see. Light is how we learn. If light is a strange mixture of possibilities, then the act of seeing is not just passive, it's active. It's a kind of participation. And that's the part that people don't teach you in school. They teach you the formula. They teach you the wave equation. They teach you Maxwell's equations. But they don't teach you the feeling of it. They don't teach you the fact that the universe is not a collection of solid objects. It's a web of interactions. And light is the first thread you pull on. Now, here's another curious thing. When you shine light on something, you might think it's just bouncing off. But actually, the light that reaches your eyes has a story. It has interacted with the surface. It has been absorbed. It has been re-emitted. It has been scattered. It has been changed. Think about a red apple. The apple isn't red because it has red light inside it. It's red because it absorbs certain wavelengths and reflects others. The reflected wavelengths are what your eye receives. The apple is not a red. It is selective. It is choosing which light to send back. So even the color of an object is not an intrinsic property. It's a property of the interaction between the object and light. And that's a key insight. The world is not a set of fixed properties. It's a set of interactions. You can't separate the thing from the way it interacts with the world. Now, let's get a little more daring. Let's think about what happens when light meets matter at the smallest scales. You might remember hearing about electrons. Electrons are tiny particles that orbit atoms. But what is an electron? Is it a particle? Is it a wave? Well, it's both. It's the same story. And the reason light behaves this way is because it's a quantum object. It's not a little bullet. It's not a simple wave. It's a quantum wave. And the wave is not a physical wave like water. It's a wave of probability. It's a wave of possibility. Now, that might sound like I'm making a philosophical claim, but I'm not. I'm making a scientific claim. because when you calculate what happens, the mathematics works, the probabilities work, the interference patterns work. It's like the universe is built out of probabilities, and what you observe is one outcome. The act of observation is what selects the outcome. Now, I don't want to get too abstract here. Let's keep it grounded. Let's go back to the double slit experiment, because that's where the story becomes undeniable. You have a photon source, you have two slits, you have a screen, and you get an interference pattern. Now, imagine you put detectors at the slits. Detectors that can tell you whether the photon passed through slit A or slit B. What happens? The interference pattern disappears. You get two bands. The photon behaves like a particle. Why? Because the moment you try to know which path the photon took, you force it to choose. You force the universe to give you a definite answer. And when it does, the wave-like behavior disappears. So the wave-like behavior is a sign of not knowing. It's a sign of the universe existing in a superposition of possibilities. The moment you demand a definite answer, the superposition collapses. Now, some people hear that and they get a bit frightened. They think, does that mean reality depends on me? Does my consciousness create reality? No, not at all. The universe doesn't care about your consciousness. The key is not you. The key is the interaction. If a detector interacts with the photon's possibilities become limited. The detector is not conscious, it's just an object that interacts, and the interaction forces the photon to behave like a particle. So the universe is not saying you exist, therefore reality exists. It's saying, when a system interacts with another system, the possibilities narrow down into a specific outcome. That's the rule, that's the story. Now I want to give you one more analogy, because I think this is the one that makes it click for most people. Imagine you're at a crowded party and someone asks, "Who's here?" You could answer, "Well, it's a lot of people." But you might also answer in a different way. It's a set of possibilities. Because in a crowded party, you don't know who is where. You might say, "The person wearing the red shirt is somewhere near the snack table." That's not a definite statement. It's a probability. It's a guess. Now, if you walk into the room and look around, you narrow down the possibilities. The moment you see the person, you know where they are. Before you looked, the person was in a state of possibility. After you looked, they were in a definite state. Light is like that. Before you measure it, it exists in a state of possibilities. After you measure it, it becomes a definite event. Now, you might ask, but what is the light really doing when I'm not looking? That's a question that makes a lot of people uncomfortable, because it implies that reality is hidden from us. But here's the point: physics doesn't give you the answer to what's really happening. Physics gives you a model that predicts what will happen when you do experiments. And the model works. It predicts interference patterns. It predicts the results of detectors. It predicts the behavior of atoms and molecules. It predicts the behavior of the entire universe. So the question of what's really happening is not a scientific question. It's a metaphysical question. And metaphysics is interesting, but it's not physics. The important thing is that the model of light as a quantum wave of probability is incredibly successful. It's not just a story, it's a tool. It's a machine that predicts reality. Now, if you've followed this far, you might be feeling a sense of awe, or you might be feeling a sense of discomfort, or you might be feeling both. And that's good, because that's the feeling you get when you start to understand something profound. Light is not a simple thing. It's not a straightforward phenomenon. It's not a small detail of physics. It's the key that opens the door to the deepest mysteries of reality. And that's why the next part of the story is going to get even more interesting, because we're going to go deeper. We're going to talk about the principles that govern this behavior and why the universe is structured in such a way that light behaves like this. We're going to talk about how light is connected to time and how it connects to the idea of reality itself. But to get there, we need to understand one more thing: that the behavior of light is not a bug, it's a feature. It's not an error in the universe. It's the way the universe is built. And once you accept that, everything starts to fall into place. All right? Now we're going to go into the part where it starts to feel like the universe is not just weird, but deeply logical in a way you didn't expect. You remember the double slit experiment, right? Two slits, one photon at a time, and somehow the pattern appears anyway. That was the first hint that light isn't a tiny bullet or a simple wave. It's something else. Something that contains both possibilities at once until you ask it to choose. Now, here's the thing that people often miss: the interference pattern isn't just a nice to have. It's not a decorative effect. It's the signature of something fundamental. It tells you that the photon isn't taking a single path. It's taking all possible paths. Yes, all possible paths. And this is where the story becomes truly surprising. You might say, Okay, that sounds like a metaphor. Surely a photon can't really take all paths, but it does. In the language of physics, the photon doesn't choose a path. It explores every path. It's like the photon is a little traveler that says, I don't know where I'm going yet, so I'll try every way. And then when you measure it, the universe adds up all the possibilities and gives you a result. This is not just a poetic way of talking. It's how the math works. There's a way to think about this that makes it more intuitive. It's called the path integral formulation, and it was developed by a brilliant man named Richard Feynman, who, by the way, had a knack for making the deepest things feel like simple curiosity. Here's the idea to know how a photon goes from point A to point B. You don't just consider the straight line. You consider every possible path between A and B, every one. A little curve, a big curve, a loop, a path that goes way out and comes back. Every path, each path has a little contribution. The contributions add up, and when they add up, they interfere. Some paths reinforce each other. Some cancel each other out, and the result is what you observe. Now, that sounds insane, but it's actually incredibly elegant. It's like saying the photon doesn't take one path. The photon takes the sum of all paths, and what you see is the result of that sum, and that's why the interference pattern appears. Because the paths through the two slits are not independent, they interfere. But here's where the mind-bending part comes in. The photon doesn't only explore paths through the slits. It explores every path, including the ones that go around the slits, the ones that loop backward, the ones that seem impossible. It explores everything. And you might think, wait, that means the photon is everywhere at once. In a sense, yes, but not in the way you're imagining. The photon isn't a tiny little ball that's physically in many places. It's a probability wave. It's a set of possibilities. And the set of possibilities is what spreads out. When you try to measure it, you collapse those possibilities into one outcome. Now let's talk about something even more surprising. You know how we think of light as traveling through space, like it moves from point A to point B in time? Well, that's true in a certain sense. But it's not the whole story, because light is also deeply tied to the structure of space and time itself. You've probably heard that nothing travels faster than light. That's a famous rule. But what does it really mean? It means that light defines the maximum speed at which information can travel. It defines the structure of causality. It defines what can influence what. And this is where things get philosophical. Not because we're being poetic, but because this is how reality is structured. The speed of light is not just a number. It's a boundary. It's the limit of how quickly events can affect each other. It's the fabric of reality. Now, here's the weird part. Light doesn't experience time the way you do. Think about it. For you, time flows. You age. You remember the past. You anticipate the future. But for a photon, time doesn't pass. From the photon's perspective, if you could ask it, the moment it is emitted and the moment it is absorbed are the same moment. This is not just a thought experiment. It's a consequence of Einstein's relativity. The closer you move to the speed of light, the slower time passes for you. At the speed of light, time stops. So light is, in a way, timeless. Light doesn't experience the passage of time. Light is a kind of bridge between events. And that's another reason why light is such a strange messenger. Because it doesn't just carry information. It is information traveling in a way that's outside of time. Now, combine that with the quantum behavior we've been talking about. The photon is a probability wave that travels timelessly through all possible paths. It's a messenger that doesn't experience time, and it chooses its outcome only when it interacts. It's like a letter that's written in invisible ink, traveling through a world that doesn't care about time, and only becomes readable when it hits the right paper. That's light. Now, you might be thinking, okay, that's all very abstract. How does this connect to reality? How does this affect my life? Well, it affects everything. It affects how the world is built. It affects how atoms bind together. It affects how molecules form. It affects chemistry. It affects biology. It affects your eyes. It affects your brain. It affects your ability to see this screen. And it affects the way the universe behaves at its most fundamental level. But let's stay with the concept for a moment, because there's one more counterintuitive truth that I want to share, and it's one of the most astonishing. Light doesn't just behave like a wave or a particle. Light is not a wave in space. Light is a wave in probability. Let's unpack that. When you hear wave, you think of something physical. You think of water waves. But a probability wave is not physical in that way. It doesn't have a height you can measure. It doesn't have a mass. It's not a thing. It's a mathematical description of possibilities. And the weird thing is the wave function, the mathematical object that describes the probability wave, doesn't directly describe reality. It describes your knowledge of the system. Or If you want to be more careful, it describes the information available about the system. Now, that might sound like a cop-out, but it's not, because the wave function predicts exactly what you will observe. It predicts interference patterns. It predicts the behavior of atoms. It predicts the behavior of everything. So even if the wave function is just information, it's information that is deeply tied to reality. Now, here's the part that's hard to accept, and that's why it's not taught the way it should be in school. The universe is not a machine that exists independently of observation. It is a machine that exists as a set of interactions. An observation is just another interaction. When a photon hits a detector, the detector interacts with the photon. That interaction forces a specific outcome. The photon's possibilities collapse into one reality, and the reality you observe is the result. So the world is not a collection of things that exist whether you look or not. The world is a collection of things that exist when they interact. Now, that might sound like the universe is a dream. But it's not. It's the opposite. It's the most solid thing you can imagine, because the predictions are precise, the math is accurate, the results are consistent, the universe is not random. It's probabilistic. That's a crucial distinction. Random means chaotic. Probabilistic means structured. The universe is not a chaotic mess. It's a beautifully ordered set of probabilities. And light is the first place where you see that order. The interference pattern is not random. It's a pattern. It's a structure. It's the result of probabilities adding and subtracting. Now let's get to the most important point of all. If light behaves like this, then reality is not made of solid objects. Reality is made of relationships. Light is a relationship between an emitter and an absorber. Light is a relationship between a source and a detector. Light is a relationship between the universe and itself. And when you realize that, you start to see the world differently. You start to see that the world is not a collection of objects with fixed properties. The world is a network of interactions. The world is a web, and light is the thread that holds the web together. Now, I want to tell you something that I think is the most important lesson from all of this. People like to think that science is about discovering facts, but the real truth is that science is about discovering ways of thinking. It's about learning how to ask the right questions. And the question you should ask about light is not, is it a wave or a particle? The question is, what is the universe doing when it appears to be light? Because the answer is not wave. The answer is not a particle. The answer is process, a process of interaction, a process of possibilities, a process that unfolds in time and space, and yet is rooted in a deeper structure that transcends both. And that's the counterintuitive truth they don't teach you in school. Light is not a thing. Light is an event. It's a happening. It's a story. It's a moment of interaction. And when you understand that, you start to understand something else too. You start to understand that the world is not a static stage. It's a living performance. It's not a place where things simply are. It's a place where things happen. And the more you look at it, the more you realize that the universe is not a collection of objects. It's a dance. All right. Now we go to the part where the story becomes not just about light, but about the way reality itself is built. You've already seen the paradox. Light behaves like a wave until you try to measure it, and then it behaves like a particle. You've seen that it's not a simple object, but a process of possibilities. You've seen that the interference pattern isn't a decorative trick. It's the evidence that the universe is built on probabilities. Now, here's the big idea that most people never realize, because it's not taught in school the way it should be. Light is the universe's way of telling time. Let me explain. When you think of time, you think of clocks. You think of hands moving around a face. You think of seconds ticking. But in physics, time is something that is measured by change. Time is not an independent entity. It's a relationship between events. You can't have time without change, and light is the ultimate agent of change, because light is how things communicate across space. If you want to know what's happening somewhere else, you have to wait for the light to reach you. If you want to know what happened in the past, you look at light. The stars you see in the night sky are not showing you the present. They're showing you the past. Light is literally a message from the past traveling across the void. So when you look at the night sky, you're looking at history. You're looking at time itself. And that's not a poetic metaphor. It's a physical fact. Light is the universe's way of keeping a record. Now, here's where it gets even more fascinating. The speed of light is not just a speed, it's a boundary. It's the limit of how fast information can travel. It's the speed limit of reality, and that speed limit shapes the structure of space and time. It's what makes time different from space. It's what makes causality possible. It's what makes the universe coherent. Imagine a universe where information could travel infinitely fast. If you could send a message instantly to any distance, then cause and effect would lose their meaning. The future would be mixed up with the present. You wouldn't know what caused what. But because light has a finite speed, there is a structure, there is a light cone that defines what can influence what. There is a clear order to events. There is a causal structure. Light is the thing that keeps the universe from collapsing into chaos. Now, this is where the story gets philosophical, but in a way that's still grounded in physics. Because when you start to see light as the structure of causality, you start to see that reality is not a fixed thing. Reality is a network of events connected by light. The world is a web of interactions, and light is the thread that connects them. Now let's go back to the double slit experiment for a moment, because it connects to this idea in a deep way. The photon explores all possible paths between the slits and the screen. It takes all paths. It's a probability wave. And when it interacts with the screen, the possibilities collapse into one outcome. Now, here's the key question. What decides which outcome? The answer is the entire history of the system, the entire context, the entire network of interactions. That's why the interference pattern disappears when you put detectors at the slits. Because the detectors become part of the network. The detectors interact with the photon. They record which path the photon took. They create a new web of events. And that new web changes the outcome. So the photon is not just a photon. It's part of a larger story. It's part of a web of interactions. And the outcome is determined by the structure of that web. This is why quantum mechanics is so strange. Because it tells you that the world is not made of isolated objects. The world is made of relationships, and light is the most fundamental relationship. Now I want to tell you something that will sound crazy, but it's true. When you talk about light, you are talking about the boundary between what is possible and what is actual. Light is the thing that carries possibility into actuality. Before a photon is detected, it is a set of possibilities. After it is detected, it is an actual event. The act of detection is what turns possibility into reality. And that's not just a feature of light. It's a feature of the universe. The universe is constantly turning possibilities into actualities through interactions. And that's what you are. You are a system of interactions turning possibilities into realities. Your thoughts, your actions, your observations, they're all interactions. They're all part of the same process. Now, let's take a step back. What does this mean for how we think about the world? It means that the world is not a static collection of things. It's a dynamic process. It's a dance of possibilities. It's a conversation between particles and fields, between matter and energy, between light and the rest of the universe. And that conversation is what creates reality. You might be tempted to think that the universe is a machine like a clock, but it's not. It's more like a symphony. It's not a set of gears. It's a set of interactions. And light is the conductor. Now, here's the part that makes people uncomfortable. If reality is a set of interactions, then the idea of a thing with fixed properties is an approximation. It's a useful approximation, but it's not the fundamental truth. Your body, for example, feels solid. It feels like a thing. But at the atomic level, you're mostly empty space. You're a set of particles held together by forces. And those forces are mediated by light. Electromagnetic interactions are what hold atoms together. The light that binds you is not the light you see. It's the electromagnetic force, and it's carried by photons. So you are, in a very real sense, made of light. Not visible light, but the same fundamental force. And that's why light is not just a physical phenomenon. It's a metaphysical one. It's a clue to what reality is made of. Now let's bring this to a close, because we've reached the point where the story starts to become bigger than the parts. Light is the messenger. Light is the structure. Light is the boundary. Light is the process that turns possibility into reality. When you understand light, you understand the universe. When you understand the quantum nature of light, you understand that the universe is not made of objects. It's made of events. And when you understand that, you begin to see that your own existence is part of the same web. You are not separate from the universe. You are not a spectator. You are a participant. You are a node in the network of interactions. You are an event, and the light that reaches your eyes is not just photons. It's the story of the universe traveling across space and time, bringing information from the past into the present, shaping your perception of reality. So when you turn on a light switch, you're not just illuminating a room. You're activating a process that connects you to the entire cosmos. And that's what they don't teach you in school. They teach you the formulas, they teach you the facts, but they don't teach you the feeling of it. They don't teach you that the universe is stranger, deeper, and more beautiful than you can imagine. They don't teach you that light is not just a wave or a particle. Light is a way the universe speaks. And if you listen carefully, you can hear the whole story.